Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. We start our class by reciting our Surah Al-Fatiha. Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Okay, Alhamdulillah. Class. So before we start the new topic, I think it's better if we make some revision about what we have discussed in the previous lesson. Our previous lesson is about the preparing the salt solution, preparing the salt using the three methods. Three different methods based on the solubility of the salts. Can you all hear my voice clearly?
Yes, sure.
Alhamdulillah. Okay, for example, revise our, not this one, this one. This one, okay, this is the method. The suitable reaction to prepare the soluble salts. This is the adsorbed salts and the adsorbs of the other than the adsorbed salts. This neutralization between the acid solution and alkali solution, and the other than the adsorbed salts prepared by 4 different reactions. Except of the unreactive metal salt solution, for example, copper chloride cannot be prepared by the acid react with the copper metal. The rest of the unreactive metals can be prepared by using the reaction acid and metal oxide, metal hydroxide, metal carbonate. Okay. All right. I want to emphasize here that metal hydroxide here that you can see to prepare the other than salt. So metal hydroxide must be different with the alkali solution here. Metal hydroxide here is only in the solid state. Okay, that's why I think in our textbook it is not recommended using the metal hydroxide and acid, not to be confused with the adsorbed salts solution in the alkali solution. Alkali solution must be contains the hydroxide. Yes, for example, potassium hydroxide solution. Okay, so potassium, sodium hydroxide, and the other one must be in the alkali solution. Okay, the reaction number 2 here is not recommended, but still can be used to prepare the salt. Okay, I hope you have not have no problem with all these reactions, and we move to the third method. The third method is using preparing the insoluble salts by the precipitation reaction, or we call that the double decomposition reaction, only to be used to prepare the insoluble salt. The way or the reaction between the solution contents of the ion, cation X, and another one, anion Y, to to produce the insoluble of salts X and Y, insoluble salts of X and Y, XY. Okay, and the procedure in the experiment also have been discussed. This is an insoluble salt, and also as well as the soluble salts. All right, all of them are already being discussed in the previous lessons. Now we want to make discussion in the question. For example, question number 21. This question is already given in your group. Question number 21. Which of the following which of the following method is suitable for preparing silver chloride salt in the laboratory? We have to know that the what type of the silver chloride salt based on its solubility. Right? So what is the answer? A, B, C, D. D. See the add silver nitrate solution into sodium chloride solution. Okay, that's very good. That's right. Since we know that silver chloride salt is an insoluble salt, yes, we can only be prepared the silver chloride solution using the soluble salt solution. All of the reactants or the solution must be in the solution. For example, as silver nitrate and sodium chloride. Yes, very good. Okay, why don't we use the A one? Flow chlorine gas to hot silver metal.
Maybe because chlorine gas isn't an ion.
An ion. Uh, it's not exactly. We know that argentum is a metal, and argentum or silver is a metal in solid state, and chlorine gas. Okay, we can see that. Okay, yeah. In a hot condition, okay, in the hot condition, uh, the silver metal can react with the gas. So here, ya Allah tak sab. Takutlah. Okay, wait for a while. Okay, okay, baru kena. Okay, let me look at the scenario here. Okay. See, for example here, okay, this is the example. For example, silver oxide. This is a, for example, this is a, for example, sodium chloride solution. Okay. Oh, sodium chloride. Uh, example, hydrochloric acid solution, and this is silver oxide. Okay, we know that silver oxide is hydrochloric acid and silver oxide. Okay, can be reacted with the uh, silver oxide to produce, and this is water. Okay, oxide. Okay, also can be reacted. So the reaction between the base and acid to produce salt and water, neutralization reaction, right? Okay, silver chloride is a solid. Okay, this is a solid. Okay, when the silver chloride is formed, so the formation of the silver chloride is will be cover the surface of the silver oxide inside the silver chloride. So this at the outside the layer of the silver oxide here, okay, is the silver chloride. This is a silver chloride. This is okay. This is silver oxide, and this is silver chloride. Okay. Okay, silver oxide and hydrochloric acid can be reacted to form silver chloride. Okay, and silver chloride form will be covered the surface of the silver oxide. So the formation of the silver chloride here will cover the surface of this. This means that the silver chloride form is not 100% pure, because the inside of the silver chloride, in the inside layer of the silver chloride, still having the silver oxide. Okay, the silver chloride is a solid state. We cover the surface of the silver oxide from the to react continuously. Okay, dan menghalang daripada silver oxide ini daripada bertindak baras seterusnya, sebab dia dah tutup permukaan itu. Okay, tutup permukaan itu. Jadi silver chloride ini terbentuk juga, tetapi tidak tulen lah. Sebab apa? Silver oxide ada dalam. Dia boleh bertindak balas, tapi di luar saja. Dalam dia masih tutup. Jadi maknanya tak sesuai. Sebab itu tak sesuai kita gunakan asid ni dengan satu larutan, satu pekerjaan. Okay. Begitu juga dengan yang panas tadi tu. Chlorine gas and silver, okay, boleh tindak balas silver chloride. Tapi kalau kita tahu katalah ni silver, okay, chlorine boleh tindak yang panasnya. Luar saja. The outside layer of the silver, okay, covered the inner layer of that contain the silver, still not reacting with the chlorine gas. Okay, so masih juga bertindak balas, tetapi masih juga terhasil ini, tetapi masih tidak panggil tak tulen lah. Kat sini. Dia faham tu?
Faham cikgu.
Macam jadi dia mesti apa? Bentuk ion bebas. Bila ion bebas, dia tak ada siapa yang nak halang dia. Silver ion and chloride ion. Kalau kat sini bebas, jadi satu ion dengan satu ion, cation dengan anion react together. So kita panggil conjugate lah, berkahwin dekat situ, senang. Jadi semuanya lengkap. Tak ada siapa, dia tidak menghalang yang lain lah. Okay, kalau tengok tadi the question, okay, this one, chlorine gas, solid tak boleh. Tapi we have to understand why the solid substance cannot be used to prepare the insoluble salts. We have to understand in that way. Alright. Okay. B, powder into the, ni pun sama, ni cikgu yang terang tadi lah. C, K, add silver oxide powder into dilute. C and B sama. Silver powder, silver powder. Silver powder totally cannot react with hydrochloric acid because silver is very, very unreactive metal. Okay. Same with the same as when we use copper. Copper also very unreactive metal, so cannot be react with hydrochloric acid or any acid. All right. So the most possible way to possible reaction and very suitable to prepare the silver chloride is D, solution and the solution. Okay. Okay. Question number 18. Question number 18 here. Which of the following ions produce a precipitate when ammonium sulfate solution is added? Okay. What the answer?
C.
C, calcium ion and 4 lead 2 ion. Okay. What the other students? How about the other student? Can you all agree with the answer?
Yes.
And Akila, how about your answer?
Same, teacher.
Okay. Why do you think it is the right answer?
Because
So you choose the C, 2 and 4. So what is the idea? We have to know what the reaction take place in this mixture of the solution. What is the reacting particles takes place? How do you know that the precipitate will be formed? Two is calcium ion, lead 2 ion. So what is the idea? Husna? Okay, Husna. So what is your idea? How do you answer this question? Maybe what yes. If you want to answer this question, the basic concept we have to know is apa dia?
maksud basic concept cikgu tu macam mana?
Maksudnya kenapa pula kalsium ion itu dengan lead to ion itu akan membentuk mendakkan tu? Apa yang menyebabkan membentuk mendakkan? Mana tadi? Ni. Kenapa pula campur ammonium sulfate dia ada bentuk mendakkan? Jawapannya awak dah, kalau kalsium ion campur dengan ammonium sulfate bentuk mendakkan. Lead to ion dengan ammonium sulfate, yang lain-lain tak boleh mendakkan ke? Jadi apa dia punya idea dia kat situ? Kalau kalsium ion dengan ammonium sulfate ni membentuk apa? Betul ke jawapannya C tu? Awak jawab lain ke?
Sebab lead tu sebab lead sulfate tu is insoluble salt.
Yes, lead to okay. So what are the reacting particle actually in the mixture takes place in the reaction? The reacting particles mean what? The name of the ion itself. Lead to ion.
Sulfate ion.
Yes, lead to ion react together with sulfate ion to produce lead to sulfates. As we know that lead to sulfate is insoluble, so that's why we'll get the precipitate. Yeah? The lead to sulfate will be formed as a precipitate. Alright? Same as to the calcium ion. If we want to mana tadi this one ini okey, kita tengok macam ni lah. Lead to ion and sulfate ion, okay, to form lead to sulfate. So lead to sulfate is a insoluble salt. This is aqueous, aqueous. Okay, aqueous. Alright, understand? Same to the calcium ion. Okay, sulfate ion. Okay, form calcium sulfate, solid state. So I need aqueous. Okay, need aqueous. Aqueous consists of calcium ion and sulfate ion provided by the ammonium sulfate. They act together to form the calcium sulfate precipitate as a solid. Macam itulah kita nak faham dalam soalan-soalan itu. Jadi kita kena analyse macam tu. Ini contoh soalan. Okey, bagus. 2018. Yang lain boleh faham tak? Rafi macam mana okey? Rafi?
Boleh cikgu.
Okey okey.
Boleh.
Aluminium ion, tak boleh apa-apa ni semuanya. Okay. So what ions other than calcium ion and lead to ion that can be react together with sulfate ion to form the precipitate?
Barium.
Yes.
Barium.
Alright, good. Barium ions. Now you have understand this. Stern already. Right, very good. Okay, base dekat soalan tu lah, base dekatnya. Okay. Tak ada lah. Okay. Okay, habis dah tu. Okay, kita nak masuklah kepada tajuk yang seterusnya. Yang ini lah Okay ni ya. Ini mana yang ada bahasa Melayu, bahasa Inggeris tak sempat nak translate Okay. Our topics today is constructing the ionic equation using the continuous variation method. Continuous variation method is a method to construct to ionic equation. We know that the concepts of constructing the chemical formula by its or by the ions. For example, the precipitate or the insoluble salt of AXBY from the cation A and the anion B. Okay, so AXBY based on what is the mole of cation A that can be related with the mole of the Y mole of B. Okay, so we have to determine what is the mole of the cation A and determine the mole of the ion B, the anion B. So this method is actually to determine what is the mole of the cation A and the number of mole of anion B. Right, It's called the ratio of the mole in the reaction will determine the chemical formula of the salts or insoluble salts, precipitate. This salts precipitate. Okay, this is the activity. Okay, so in this activity, for example, at page, I don't think what is the page here. 188 of your textbook. Okay, construct an ionic equation for the formation of lead 2 iodide. Lead 2 iodide is a type of the insoluble salt, iodide. Then iodide, other than in the group of 4 of the salt that we have discussed, we have already known the salts, nitrate salts, sulfate salts, carbonate salts, and the other one, chloride salts. Okay, lead 2 iodide is just we want to know the another type of salts. Okay, this is, you can see clearly because lead 2 iodide is yellow in color, so we can identify it clearly in the reaction. Okay, so the hypothesis, so the problem statement, how to construct. Okay, the hypothesis there. Okay, as the volume of the particle between lead 2 iodide in the reaction, we have to react between the lead 2 ion and iodide ion. Let it go. No?
Anak tanya panitia kimia ni ada kerja apa sebenarnya panitia kimia daerah. Sebabnya dia minta cikgu buat video eksperimen ni, eksperimen kimia.
Cikgu nanti boleh tak? Sekarang ada kelas lah.
Cikgu free bila?
Lepas ni, lepas iklan.
12 yang kelas tu
12 malam. Okay. 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 The formation of lead to iodide is between the lead to ion and iodide ion. So we have to determine what is the mole of lead to the number of mole of lead to ion and the iodide ion. Okay, in this reaction. Okay, so lead to ion is provided by the lead to nitrate solution, and iodide ion provided by potassium iodide solution. Okay, we cannot take the lead to ion itself. So there is no such solution. Lead to ion from the lead to nitrate solution. Iodide ion from the potassium iodide solution. So, okay, in this procedure, okay, this one, the idea dia sini. This one, okay. So in this continuous variation method, fixing the volume of the lead to nitrate solution while manipulating the volume of potassium iodide solution is to determine the mole ratio of lead to ions that will react completely with the iodide ions. So if X mole of lead to ions react with Y mole of iodide ions, then the empirical formula of the insoluble salt is PbX. This is, you have the idea. Yeah, this is the concept, the idea that we have to keep it in our mind. Okay, so macam ni. Okay, kita masukkan potassium iodide ni biasanya daripada burette ke dalam larutan dia, larutan lead to nitrate solution contohnya. Maknanya kita boleh ambil satu larutan yang which one will be the manipulated variable. We can choose the lead to nitrate as a manipulated. This means that we have to add into the test tube from the burette. You can change the solution. One. So in this experiment, we use the potassium iodide solution. Okay, as a A solution A is which one is manipulated and which one is yang mana tadi tu? Okay, yang ni. Okay, mana cikgu tadi? Yang okay, yang ni. Kita boleh gunakan yang ni. Yang manipulated and then apa nama? Fixed variable and manipulated variable. Kat situ. Jadi kita katalah kita gunakan yang ini manipulated variable dia. Okay, yang ini fixed variable. Fixed variable dia apa? Lead to nitrate solution. Okay. Yang ni, jadi maknanya nanti kita akan tengok di tindak balas berlaku lah. Bila masuk aja larutan ni, dia akan bentuk satu precipitate insoluble salt, potassium iodide and lead to nitrate, okay, will produce lead to iodide. Okay, 1 cubic centimeter, 2, 3, 4 until 8 cubic centimeter. Okay, nanti kat sini. Caranya. Okay, ni semua yang perlu kita tahu lah. Okay, the mole ini sebenarnya ada pembetulan ni, kalau tak silap ni. Ini 0.25 ni. Tak apalah. Kita tengok dari segi aspek eksperimennya dulu. Okay, kat sini kita masukkan daripada burette. Macam ni. Semuanya dari 1 cm padu potassium iodide masuk. Kemudian yang kedua 2 cm padu potassium iodide masuk dalam second test tube. Tapi dalam test tube ni semua yang dimalarkan lead to nitrate solution 5 cm padu. Okey. Semua ni 5 cm padu. Tapi yang ni kita masukkan daripada potassium iodide ini bertambah daripada 1, 2, 3, 4 sampai 8. Okey, macam tu. Kemudian kita nak tengok. Apa yang kita nak tengok dia ialah ni. The height of the precipitate form in the test tube. Okey. Jadi tinggi mendakan tu nanti selepas beberapa, katalah 15 minit atau setengah jam, dia akan kita nampak mendakan tu. Dia akan berubah. 1 cm padu dia sikit lah. Sebab sikit saja larutan kan. Ini 2, 3 dia bertambah. Makin bertambah isi padu potassium iodide solution yang kita beri, semakin bertambah. Sehinggalah 5 cm padu pada test tube yang kelima ni. Dan selepas itu dia sama saja. Sama saja. Ini maknanya pada tabung uji kelima ni dia dah cukup untuk bertindak balas. Maknanya semua ion yang kat bawah ni iaitu lead to ion kan. Yang atas tadi potassium iodide membentuk iodide ion. Yang bawah lead to ion. Okey. Yang lead yang yellow precipitate ini adalah lead to iodide. Okey, yang ni. Okey, jadi kalau kita tengok tinggi mendakan dia ni, nanti kita akan dapat macam ni. Ini bahasa Melayu, tak apalah. Okey, tabung uji pertama tinggi dia tabung uji tambah sampai tabung uji kelima dia tak tambah lagi. Okey, sebab tak tambah kat sini sebab lead to nitrate tadi dah habis. Apa yang dah habis? Lead to ion tu actually kat sini yang dah habis. Okey, dekat sini masa pun kita sampai pukul 12.05 minit je kan. Okey. Okey kat situ. Kat sini sebenarnya lead to ion plus iodide ion to form lead to iodide. Okey kat sini. Jadi yang dekat sini yang apabila asid padu larutan iodide membentuk ion iodide ditambah daripada burette, dia sampai sini tinggi dia. Sebenarnya ion iodide membentuk iodide, lead to ion bertindak balas dengan iodide. Okey. Kedua, lead to ion bertindak dengan iodide, tinggi dia sebanyak ni. Maknanya lead sampai sini saja. Jadi yang dalam lead to nitrate itu, lead to ion tu dah tetap 5 cm padu tu dah tetap. Maknanya tak bertambah lagi. Okay. Jadi sampai sini lead to ion dah habis. Bila dah habis, tak ada lagi yang dia boleh bertindak balas dengan ion iodida walaupun ditambahkan lagi. Iodida tu bertambah banyak walaupun dah banyak, dia tak boleh lagi bertambah mendakan sebab dia tak boleh lagi bertindak balas kerana all of the lead to ion has completely finished because it already react with the iodide ion. Okay, ini semua dah habis dah. daripada larutan lead to nitrate tu dah habis dah lead to ion. Jadi dia tak boleh lagi untuk nak balas. So hanya setakat ini saja dia punya hasil. Jadi maknanya setakat ini saja, ini berapa? Kita akan kaji berapa mol yang boleh kita nak balas dengan dia. Okey. Ion iodida dia berlebihan kan, sini dia berlebihan. Yang ini ion iodida sikit. Kan yang kat sini ni iodida sikit 1 cm tu. Jadi dia sebab itu dia boleh lagi kita nak balas. Okey. Yang dekat sini iodida berlebihan. Tapi ion lead to ion pun dah habis, dia tak boleh. Jadi yang betul-betul semuanya lengkap kita nak balas pada tabung uji kelima. Oleh sebab itu kita tengok berapa bilangan mol bagi kedua-dua larutan yang lengkap bertindak balas. Okey, kita tengok tu sini ni macam tu. Ini bahasa Melayu lah, tak sempat nak tulis kat sini. Okey, yang kat sini ni okey, dalam bahasa Inggeris pun ada lah okey, kat situ. Kalau kita tengok okey, pada tabung uji yang kat sini lah, ini yang sebenarnya mulanya tindak balas lengkap telah berlaku. Okey, maknanya tak ada lagi hasil yang kita bentuk selepas itu walaupun ditambah pengisida. Okey, so maknanya kat sini kita tahulah tindak balas lengkap telah berlaku kat sini, kat situ. So kita akhirnya boleh mengira dia punya bilangan mol-mol yang sepatutnya telah bertindak balas. Okey. Okey, katalah kita gunakan yang ni semuanya larutan lead to nitrate tadi tu 5 cubic centimeter with the molarity of 0.5 molar and react together with 5 cubic centimeter with the molarity of 1 molar. How do we know this is 5 cubic centimeter? So you just take from the graph, okay? This 5 cubic centimeter of potassium iodide solution has been used in the test tube 5, okay? Means that in test tube 5, the reacting mixture is completely done. Jadi sini, okay? So we take as 5 cubic centimeter used in the reaction. Okay, so we have to calculate the number of mole. So lead to nitrate solution provide the lead to ion. So the number of mole of lead to ion based on the chemical equation here is the similar to the number of mole of the lead to nitrate solution, equal to the number of mole of lead to nitrate solution. 1 mole, 1 mole, 1 mole kan. So our concern is lead to ion. So NV per thousand, we get the calculation is 0.0025 mole. Okay, and the same way we calculate the number of mole of iodide ion from the equation. Okay, NV per thousand is 0.005. Okay. Okay, yeah. Okay, kalau kita tengok sini, kita dapat calculation semua tu. Ini tadi kita kira 0.025 kalium iodida atau iodide ion. Okay, 0.005. Jadi akan membentuk lead to iodide ni. Jadi X3 tadi ini 0.05. Ni kalau kita jadikan dia nombor bulat, kita tahu yang formula ada nombor bulat je, tak ada perpuluhan. Jadi kita jadikan dia paling ringkas. Jadi kita akan dapat 1/2. 1/2. That's why lah kita dapat dia punya formula dia. PB nya 1, I nya 2 macam ni. Okey cikgu akan hantar nanti dulu slide kat sini. Boleh faham Masa pun dah habis actually ada kat sini. Tapi yang ini ni so macam mana jadi awak kena nanti cikgu akan bagi satu contoh latihan. Contoh latihan untuk jawab soalan yang seumpama macam ni. Okey, tak apa, terima kasih semua. Terpaksa cikgu berhentikan kat sini tentang